talking before that here we have two examples where referential integrity is talked about. The first one is in violation of referential integrity because the artist ID number 4 in the foreign key has no matching in the parent table. And the second one is perfectly fine because all the foreign key category IDs in the item table have matching category IDs in the parent table category ID. Okay, having said that, let's go one step back to unit number 10. In unit number 10, besides that, we also have an SQL tutorial PDF. When you open that, you will be taken to this SQL, which is a 30-page PDF document. It's the first couple chapters, or I would say the first 5 chapters of this book called SQL Tutorials. And that is more than enough for you to understand the concepts. As you have already learned that SQL is a way for you to communicate with the databases, and SQL is implemented through several different vendors, but they all have to adhere to SQL standards. They all have their own little things that they do to give themselves a little bit of an upper hand over a competitor, but the bare basics of SQL they all have to follow, which is called the SQL standards. Why SQL? Because SQL allows you to communicate with the databases, and especially relational databases. You can do several different activities with them using SQL. Here is a brief history of SQL, divided in years, and the SQL process is being talked about after that. That anytime you query an SQL is a structured language, so it has to go through a query language processor, where it tries to understand the command that you wrote to see if it is syntactically correct. If your command is syntactically correct, your command is then passed over to a database engine. The database engine then looks at your command and then tries to access the resource that you're asking for on the physical database, and then brings the data to you or fulfills your command. So this is the process through which an SQL query goes through. As I told you before that we have DDL commands, DML commands, and DCL commands and their purposes. And what is a relational database management system? Again, it talks about what is a table, what's a field, what's a record, column. Null value means no value. It doesn't mean 0 or a space. Null means nothing. And we already talked about SQL constraints, but we mainly talked about foreign key and the primary key constraints, which are formed through the referential integrity. There are other kinds of constraints like not null constraint, where you cannot leave the field empty. You have to enter some value when you're doing data entry. Similarly, you have default constraint. That means if no value is provided, the default value will be given to the column. Then you have check constraint, which makes sure that the values entered in the field adhere to the rules of the field. For example, if nobody in your organization can be paid less than $30 an hour, then you would put a constraint on the field hourly pay at least 30. So if anybody tries to enter a value less than 30, it will not let them do that. So that's a check constraint. Index constraint is that all the fields on which the index is placed, those fields are performance efficient. So they have keys on them, just like we have physical files with keys. So their retrieval rate is faster. Normalization is outside of the scope of this course. We don't have to worry about normalization, but just to see the SQL, that's why this page is important for you to see the SQL. When you're writing an SQL command, let's say you want to create a table. So you go about issuing a command called create table. So create is the command. Table is the kind of object you want to create. So if you want to create user, you'll say create user. If you want to create a view, you'll say create view. So whatever object you want to create, you follow that by the name of the create command. So create table. Then you mention the name of the table that you want to create. Then you open the parentheses, you close the parentheses. And between the opening and the closing parentheses, you list your fields. Every field must have a data type and, if possible, a constraint. But constraints are not required. But what is required is, if the field data type requires a length like a varchar or a char, then you are required to provide the length. No comma after the last field, but all other fields will be comma separated. Any question about the syntax? Okay. Here is an example where you have multiple fields being promoted to the primary key status. Notice that first we list all the fields, and then towards the bottom we are like, okay, these two fields are primary key. So when you have multiple fields promoted to the status of primary key, we call this composite key, composite key. Anytime you hear the word composite key in databases, it means the table has more than one primary keys. Okay, now let's go down to a table with one primary key versus a table with two primary keys. One primary key, multiple primary keys. Okay. Let's see. It just goes with like through the history and stuff like that of different databases. If you are selecting data from a table, you write select, then you start listing the columns that you want to select. Every column will be separated by a comma, but no comma after the last column, from and the table name, and that will retrieve all the data from that table. So that's what, again, we'll be briefly looking at SQL here. We'll not be looking at it in great detail. If you want to insert data, then you put insert into a table name. You list all the columns in which the data will be placed, values, and then you list all the values for those respective columns. If you want to update, then you say update table, set column number 1 equals to this value, comma, column number 2 equals to this value. So you list all the columns that you want to update. Delete from table. If you just write this instruction, it will delete everything. But if you want to conditionally delete some of the items, then you would use the where clause. Okay. Yes, Kevin. We have an actual entire course on database programming in 4th semester. That's called DB2 UDB programming. And that course is all database programming. So we will be briefly, that's why we are briefly touching base with SQL the 1st semester. You will see a little bit of SQL in the 3rd semester in IBM and .NET. And you will see, again, I mean, some more, you will also see SQL in your Intro to Programming class also. So 2 classes in the 1st semester touch base on databases. 3rd semester goes a little bit deeper into databases, but main database class is 4th semester. Okay. There are no database classes in the 2nd semester because 2nd semester is heavy on object-oriented programming. Because in the 1st semester, you guys are only introduced a little bit to object-oriented, maybe like a week. So semester 2, the focus is object-oriented programming and control language, which is step 2 of this course. So we did not want to do, and also internet programming. So you get to learn about the client-side internet technologies, HTML, CSS, JavaScript kind of stuff. So we did not want to put too much stuff in a semester. So only introduce some information and then move on to the next step and then introduce a little bit more information and go like that. Okay. There were times when, when we had a different structure and students had to take a lot of classes in one semester, and they were all brand new stuff and they were going crazy. But we changed that model that every semester you see fewer newer things, and most of the things are like add-on to the previous semester. So that's basically the approach we are taking now. Okay. So to get rid of the table, you can say drop table, table name. To get rid of the database, drop database, database name, and so on and so forth. Okay, now let's get to the hands-on with DB2 in particular. So there's another tutorial I've got for you guys, DB2 UDB SQL tutorial. Click in that link. On the right-hand side, you get to see all the commands. So we have select, order by, where, and also they're listed right here. There's several different commands that are being talked about here. So if you go to section number 12, which is data definition language, this will be our starting point, where click on create table. Look at the syntax of the table. This is the same syntax that you earlier saw in the other tutorial. Create table, table name. Within the parentheses, you list all the fields. Every field needs to have a data type and, if possible, constraints. Okay. So this is what we will be following as our example one. So let's go back to green screen. And on the green screen, oops. On the green screen, we will now be going into a utility called STR-SQL. So the name of the utility is SQL. And hit enter. So far, so good, everybody, with me in the green screen? Okay. Now, can one of you tell me name of an object from real life? I am not. What object is that, Megan? Okay. I don't know if you want to type something else. Okay. Okay, so we'll wait till Megan also gets to the green screen. But in the meanwhile, I'm not working on the green screen. I'm just filling up some details in the notepad. So hopefully by the time I'm done with the details, you will be in the green screen. Okay. So computer, let's take computer, for example. Computer is the name of my object. So object is computer. Okay. Now let's look at some of the fields that could define a computer. Brand, model, price, right? Some of the specs like that. Type, like if it's a laptop or a desktop, whatever it is. Okay. Now, let's say brand, model, price, and type. What do you think is a good data type for brand? Character or variable character? No, we're looking for data types, Caleb, not values.
Varchar.
Varchar, okay, because brand names could vary in length, like HP is only 2 letters and Apple is 5, okay. What could be the data type for model? Because models also vary. Varchar, okay. And for price, it got to be one of the number types. So when we were looking at this example here, we saw integers, but integer is not really a good choice for what? For price, correct? What other data types did I share with you here that could go decimal? Okay, decimal. Oops, where'd that go? Decimal. And then the type will also be a variable character, means if it's a laptop or a desktop. Okay. Now let's talk about the length. What could be a good length for a brand name? Like how many characters? 20? 20, isn't that too much, too long? Do you know of a brand that's 20 characters long? Or maybe 10? Just to be safe, you know, somebody comes up with, okay. That's too safe. Usually brand names are smaller. They want people to remember them unless it's a clothing brand, and then they have crazy names that you can't even pronounce. Models. Price. What could be the maximum number of whole number digits a computer could cost? $10,000, right? There are computers that are 10 grand or more. And then that's 5 plus 2 for decimal. So 7, 2. And the type probably. Okay. So those are the details I have drafted for myself. We thought of an object. We listed the information we want to store about this object. And then for each of the items, we listed some data types. Okay, so let's take care of Megan here first. I'm exiting out of here. And okay, Megan, you have been enabled. Let me know, Megan, when you're in. Okay. Okay. So it is str SQL when you're in, and that will take you to the screen. Now I will keep this information here on the side so that I can see it while I'm typing it. So the name of my object is computer, but I need to start working with SQL commands. Create, what am I creating? A table. So table. What is the name of my table? Computer. So, okay, so these are the three things. Create table, computer. What do I put after that? Create table, computer. What is the next thing that I put? Parentheses. Parentheses. Okay. I could go to the next line, or I could continue typing on the same line. Remember, we have only so many characters per line. The length of the line shows you how many characters you can enter per line. You could continue typing on the same line, or you could go to the next line, doesn't matter. Until and unless you press enter, it will not run the SQL command. So make sure you only press enter when you know that you're done. I can go to the next line, perfectly okay. I can go to the next line, but going to the next line is not part of the deal. Just remember, okay? So my first field is brand. The data type is varchar, and size is 10, comma. I could type the next field on the same line, like model, varchar, size 10, comma, price, decimal, 7,2, or if needed, I can go to the next line. Type varchar 10, and I need a closing parentheses. I'm purposely putting all these extra spaces, guys, just so that you can see the mapping. Otherwise, you only need one space in some places, and in some places you don't even need a space. So you will definitely need a space between the field name and the data type, but no space between the data type and its length. All fields are comma separated. No need to have too many spaces after the comma. Even if you don't put a space after the comma is okay, but for the readability sake, I'm doing that. Once you are done typing your command, all you need to do is press enter to run it. So I'm waiting for everybody to come this far. We'll give everybody maybe a minute or so. Hopefully everybody will be able to be done, and then press enter whenever you are done. And then you may see something like what I see at the top. Whenever I'm done creating a table, it says the following table is created, but it's not journal. Don't worry about journaling this semester. A little bit of an advanced topic for you guys. So upon hitting enter, it comes back and tells me that the following compute table was created. And this is the SQL. So anybody still in the process of writing, this is the SQL that we have written. So can you please give me green check when you guys are done? And that way I will know that you are done. And then we can move on to the next item, you know. So we are still, I think we have like missing it for Emilio, Gavin, and Xavier. So this is the object that we created. Okay, let's see. Gavin and Emilio. Are you guys having any difficulties, or Oh, still typing? Okay, that's fine. That's fine. Can you guys, in the meanwhile, give me another object? Fruits. Awesome. Fruits. Okay. Now, that's the name of my object. Now let's start looking at possible fields. Can you think of fields for fruits? Colors. Flavor profile. Okay. Go a little bit easier. Okay. Okay. So, have you been to Woodman, for example? Right? Okay. For every fruit, how do they figure out one fruit from another? No, no. There can be multiple types of apples, multiple types of bananas. For example, they have banana coming from different brands like Dole and Chiquita. So they give every fruit a category ID number, right? No. They give a category that's called, you punch in the code. For example, for banana, the code is 4011. Doesn't matter what is the brand, as long as it's not organic. All organic bananas have one code, and all non-organic bananas have one code. All cucumbers, which are seedless, or have one code. All seeded cucumbers have another code. All cilantros have one code, doesn't matter where it's coming from. All strawberries have one code, depending on, it doesn't matter who is the provider. They have different code for organic and inorganics, but they do have a code. So we need for every fruit a code, and we need for every fruit a name, and probably some kind of, company associated with that fruit, and price. Okay. Now, let's move on to the next level. So we have code, we have name, we have company, we have price. So these are the fields. Okay. What could be a good data type for code? All the codes are numbers, right? Like 4011 or 5095 or 3336. All of these are numbers. So this would be a good candidate for a character size 4. And why not integer? Because we're not doing any calculations with it. So the numbers that have some calculations attached to them, they're good candidates for integers. Name of the company. Oh, sorry, name of the fruit. Variable character. What could be a good length for a fruit name? 8. Now think about it. You cannot sell strawberries then. Kyle and Megan, you guys can't sell any berries. Well, apples are too expensive. They are very expensive, right? Yeah. They start at $200. Too expensive. You can't go apple. Is lemon a fruit or a vegetable? Fruit? Okay. There's a very interesting lemon I noticed at Woodman's. I didn't know that it was lemon. I'll show you how it looks like. And they'll be like, really? Even I did not know it was a lemon. That's called Buddha's hands or Buddha's palm, something like that. That's the name of this fruit. It's in the specialty section by, where the onions and potatoes and, the other exotic fruits are, that's where it is. I have no idea. My wife asked somebody who was shopping around. They're like, oh, that's lemon. It's like, oh, okay. That's pretty cringy, lemon. That's scary, does it only comes around the Halloween time? I don't know. But yeah. So that kind of name would require longer than 6-8 characters, right? Rambutans, right? Yeah. Or do you guys know what fruit is this? No, no, it's not jackfruit. No, no. This is custard apple. Very sweet. They're all seeds, and basically you eat what is around the seeds, this white area. So the whole point is to show you all of these different examples is that we have varying lengths, like custard apple. Think about how many characters you need. Custard space APPLE. That's 13 characters. So we will go with 20, right? Safe. We're not even going in the longer names. For example, a red delicious apple. That's one category, right? RED space DELICIOUS space APPLE. That's 19. Yes, that's what I'm going to give Dylan his 20, right? Okay, company. So company, we're going to give 20 as well. Price. Decimal. What could be a good size for the price? Have you guys heard of white jewel strawberries? White jewel strawberries? Oops. Yeah. Those are $10 a unit. It's pretty expensive. And when it comes to apples, yeah, the Japanese apples, they are even more expensive. Each apple will cost you around $20. And there are special Japanese luxury fruits called ubari melons. Ubari. Yeah, Yubari. And they cost you $200 a piece. And interesting enough, there are special mangoes which are called Miyazaki mangoes, and they can be priced anywhere between, you will be shocked. I don't know. I don't know. And there are special grapes called ruby Roman grapes. Only 24,000 bunches are produced on yearly basis. So these single bunch could cost around $90 to $450 a bunch. And we have not yet hit the top of the list. Special pineapples that are grown in Cornwall's Lost Garden of Halligan in the southern England. Each pineapple, guess how much it costs? Close enough. Yep. Yep. Close to $16,000 per pineapple. Yes. Yeah. So there are some fruits that are extremely expensive. Again, I'm just talking about these things so that, you know the kind of business you are in. Of course, Woodman's would not go for that large of a number to store information, but probably they will be okay doing 4-2. But depending on the kind of store you are in, you may go with different numbers. Okay. So this gives us some specifications to create our next table. Gavin, you're caught up now, right? With your previous one? Okay, cool. Now let's put this together, guys. Okay. So let me put this on the side so I can see it. So I will be creating. You don't have to do it in caps. I just do it in caps. It just makes it a little bit more readable. Create table, fruits, code, character, size 4. I want this to be my primary key. And when I say I want this to be my primary key, it means no other fruit can share the fruit code with any other fruit. So all fruits must have a unique code. Then name, variable character, company, variable character, and price, so as you see over here, I maximized the space on each line before I went to the next line. It's possible to write one field per line. In my previous example, I did not declare any field on the line where I opened the parentheses. Anyway, whatever you want to do it, however you want to do it, pressing enter will create the table for you. Now, the next step would be to start putting data in the table. So for that, we use insert command. Insert into fruits, and I will first list my fields: code, name, company, price. And then I can list values. All the character values will go in single quotes, like 4011, banana, dole, and 109. So 4 fields, and the respective values will go in each field. Pressing enter will add the data, just like that. Okay, everybody got this? So now let's try to learn how you can insert more than one records in the same SQL command. Simply press F9 on the previous one, and it will be all written out for you. If you enter the same code again, it will error. It'll error out because you cannot use the same code twice because of the primary key. I want you to try this. Press F9 and simply hit enter. And it will yell back and say duplicate value was specified. That's why the insert did not go through. Okay, so now let's change the codes. 4503, 4053, and strawberry, dole, 299. Remember, I'm doing multiple inserts. So I'll put a comma and I'll start listing my next insert. Do not need to repeat the word values. So I'm going to start my parentheses. 4067. Watermelon. 999. Oh, sorry. I don't know. I'm just making up company names. And when I press enter, all 3 rows will be inserted in one shot. You have to remember to put commas between each record, though. Okay. Everybody just done with this one as well? Oh, not yet. Okay. So I believe everybody's done. Nobody is behind, right?
Mine said number of columns not consistent when I tried to
Okay.
submit
Okay.
it.
Okay. Check the number of columns. You have 4 columns listed at the top, and you have 4 values listed. Are all values comma separated?
I'm checking right now.
Mm-hmm.
I probably did miss one.
Okay. So you can insert one record, or you could insert multiple records. Okay, now let's delete one of the records. Delete from fruits. Well, if I run it like that, all the records will be deleted. I do not want to delete all the records. I want to delete only one of the fruits. So I can say where code equals to 4444. So only delete that record where the code is 4444. So only that record gets deleted. So where clause is what we use to filter the records. So one row is gone. So if you have character data, then it must match in case. So if I wrote apricot in all uppercase, and if I try to lowercase any of those letters, then it will yell back and say, record not found. So you have to make sure with character data that you match. How can I make sure that all the data is gone? Select star from fruits. Select asterisk from fruits and hit enter. You will see all the data that you have entered into fruits, but the line with 4444 code is gone. You deleted that. That's what you see. You see everybody but 444. So you can hit F12 and that'll take you back. Don't hit F3, F12. Okay, now let's do an update command. So let's try to update the price of strawberry. So update fruits, set price to $4.99, where code is 4053. Update fruits, set the price to $4.99, where code is 4053. It'll tell you one row updated. Okay. Now, how do you make sure that it was updated? Press F9 2 times, and you will see the select command that you wrote before. So you don't have to retype it. And this, press enter. So I pressed F9 twice, and then I pressed enter, and I could see that strawberries are now $4.99. F12. So we looked at create command, we looked at insert, delete, update, and select. These are the main commands that we typically see. Now let's try to insert another fruit, let's say blueberry. So blueberry, I can press F9 a few times till I can see the insert command, which was done to enter one record. So now let's say I would like to enter a code for 111. The fruit name is blueberry, comes from Dole, and the price is, let's say, 99 cents. So I've inserted one more record. To make sure that the record went through, of course, you can do select star from fruits, and you can see that blueberry is part of the deal. So insert the record and make sure that the blueberry went through. Now let's do a little different kind of selection. F9 with a where clause. Select star from fruits where company equals to Dole. So that means you are only selecting those records where company name matches Dole. And press enter. And you can only see those records where company name is Dole. So select all records from fruits where company is Dole. Now press F9, and instead of equals, add an exclamation mark that makes it not equals to Dole, and hit enter, and you will see everybody but Dole. So not equals to as an exclamation equals to. Press F9 again. You want to select all those fruits where the price exceeds $2. So price greater than 2. And press enter. And you will now see all the fruits that cost more than $2. Okay. Now let's say I want to see all those fruits that cost more than $2 and the company's Dole. Okay. So the cost is, the price is more than $2 and company is Dole. The way we say it is the way we write it for the most part. So SQL is a little bit easier to work with. Now think about it, if you had to do this with physical files, you had to actually write one physical file for each of these criterias. Here we just write a single liner and we have the output. We don't have to have the output create, it's like logical files. I mean, you have to create logical files. There is no way to do a memory query with logic physical files. You have to create objects to interact with them. Okay. So now we get, that's the only fruit that comes from Dole and costs more than $2. Okay. F12. Now, F9 again. I want to see all those fruits where the price is between 1 and 3. So you can use a between clause to give a range. It's equivalent to the range keyword. So where the price is between 1 and 3, you hit enter. And that's the only fruit that the price is between 1 and 3. Let's say if I want to get all the berry fruits, so I can say, give me all the fruits where name, like is an operator to look for patterns. So strawberry and blueberry, they both end in berry, right? So I will start by saying asterisk berry, means whatever, but ends in the word berry. So the pattern is starts with whatever, but ends with the word berry. And when you hit enter, it will give you all those entries where the fruit name ends with the word berry. Oh, hold on a second. 12. Oh, my bad. My bad. It should not be asterisk. It should be percentage. I got carried away between Microsoft and DB2. Should be percentage symbol.
Can you also not use contains?
No, it doesn't. No, no. So that will work. And remember, these are keywords, not functions. There's the difference between functions and keywords. Functions always have parentheses and stuff like that. For example, if I want to see the total of all the fruit prices, then I can say, okay, select sum of all the prices from fruits. So that will give me one total of all the fruit prices, and that's $17.06. Or if I want to see the average price of all the fruits I sell, and I hit enter, and I see, okay, this is the average price of all the fruits you sell. Again, you know, we're just touching base with only a handful of things. So we basically looked at chapters 9 and 13 today. And again, as I said, we are just briefly looking into SQL. A lot of the things that I covered, the SQL part of that is chapter 13. And some of the earlier commands we did on green screen, that's chapter 9. Okay. So I'm not giving you any quiz for this week, considering it is Thanksgiving break, but giving you an assignment. But this assignment is not a hands-on assignment. It's finding answers to some of the questions. And these questions are coming from page 456. You just answer these 4 questions. Question number 2, 3, 4, and 7. So you would have to find answers to these questions in the chapter. And that's all. And one more item I am giving you is the YouTube database tutorials I created. Like in the past, I shared with you short tutorials on physical files and logical files. So when you click on this link, there are a couple of short tutorials. You know, one is 7 minutes, the other one is 5, talking about the concepts about SQL that we talked about earlier. And the hands-on is part of the recording that I will share with you guys. So that's all from me today. And have happy Thanksgiving, everybody. Some of you I will see next week, Wednesday, for the Intro to Programming class. And for those of you that I do not see, have a good Thanksgiving. We'll see you in 2 weeks. We'll see you on December 1st. So we'll see you in December next time. Wow. Right. Okay. Any questions though? Awesome. I hope you had fun learning databases. And we will explore one more database tool, but next time. A little bit more color, pretty, not green screen, but that's for next time. It's not RDI. It's outside of RDI. It's not within RDI. Okay, guys. We'll see you guys next time. Till then, good night.
Bye.
Bye. Yes, Alex. Okay, let's see if anybody has. Okay, Nikki, let me check because I have tons of emails. Sometimes I miss an email. Possible. Just give me 1 minute. Let me hop into my email. It's loading. A little bit slower. I don't know why. Oh, wait. Oh, the one that you sent earlier this week. Oh, that's fine. That's fine. You know, I will use this email when grading that. Yeah. Not to worry about that. Thank you for reminding though. Awesome. You two have a good day. Kevin, do you have any questions for me?
Yes, I do.
Yes.
Sorry, I didn't want to bring up anything earlier, but so I was working on the assignment. I'm 90% sure I'm 90% of the way there. I'm just confused on the like, do you mind if I share my screen with you?
Yeah, go ahead. And we are talking about Unit 9 assignment, right?
Yes, sir.
Okay, cool. Let's see.
I don't know why I can't share my screen.
You should be. It's enabled for all the participants.
Oh, here we go. It's just
Okay.
So I don't know if it's sharing right now, but there we go.
It's loading on my end, and okay. Okay, so you have created a lot. Oh, on the very first line, there should not be a space after J file.
Oh,
Yeah.
I've been trying to fight with this, and none of the tutors can help at all. So
And I believe one more thing would be that you have a common field, right? Pub ID. So go in the
yes.
line of the common field and go under functions and type JREF and in parentheses #1. Because the common field, it needs to know which one of the two files it's coming from. Enter.
I'm so sorry.
Hit enter or apply, and here it is. And then you can save the changes and let's compile.
That makes so much more sense. I've been fighting this left and right, and I was like, okay, continue to watch the videos. I'm like, I'm missing something.
Okay. Okay, field not found. Can we have a look at your books and publisher? Can you click on books? No, it's already opened. Title, author, pages, pub ID. Okay, now go to publisher. Pub ID, pub name, public. Okay, now go to book info 4. pub ID, pub name. Okay.
I don't think I mistyped anything.
Well, just 1 second, okay?
Yeah, not a problem.
I took a screenshot of your logical file. Can you now go to books.pf? Yeah, okay. Yeah, title and author from. Oh, here's a mistake. Go back to your book info 4, click on pub ID, and go to. Okay, you do not need to mention the field size for the logical file. So get rid of that 5 and get rid of that A. So go in the column of A, choose nothing. Yeah, and hit enter. And like that, repeat that for all the fields. Because it's borrowing the data.
that's-
It's not creating the fields.
Rather than trying to recreate them. Okay.
Okay.
Because I was trying to follow one of there was I forgot if it was in the presentation. I was trying to follow one of the guides trying to go through with it, and I was trying to just copy and go through, and hopefully it worked. Okay,
Okay,
so let's try.
now let's save the changes.
Um,
And okay, now double click on the first error, please. Oh, that should be pub ID, not zip. Oh, I think you copied that from a different example. So hit F4. Okay, the common field in our example is pub ID, not zip code. Right?
Yeah. Field.
So pub ID space and then pub ID. Enter. Save changes. And